Thank you guys for joining this session. We're going to sort of get started now. Time's kind of up. Really appreciate you spending the time to come into ours. We're going to be going through the looking glass, looking at effective observability for cloud-native applications. So if anyone who's not met me before, hi, nice to meet you all. My name is Grace Jansen, and I'm a developer advocate at IBM, and I'm co-presenting today with Reece. Do you want to introduce yourself?
Yep. Hi, everyone. My name is Reece, and I'm a software developer intern at IBM in Grace's team.
Yep. Fab. So we're going to be co-presenting this today. I'm going to be running through most of the presentation, then passing over to Reece to show you this hands-on, because we're all developers, and we want to see how this actually works. So without further ado, I'll get started with sort of really diving into this topic. So the first thing is, what do I mean by through the looking glass? Why did I choose this title? Anyone familiar with Alice in Wonderland? Hopefully from when you were a kid? Yeah, fantastic. Okay, if you're not, you should get my second reference, hopefully, with my brilliant GIF. So through the looking glass, this is a phrase that was really coined by Lewis Carroll way back when sort of the Alice in Wonderland adventures came out in books. And really what it really means is it's all about Alice's adventure in the sequel to Alice in Wonderland, which is called Alice Through the Looking Glass. There's a film. You might have seen it from Disney. It came out quite recently. And it's all about how she passes through a mirror over a fireplace and finds herself once more in the enchanted land where she met sort of the Mad Hatter and the Queen of Cards and everyone else in that world. So it's all about sort of passing through. It's this metaphor for any time that we sort of suddenly appear somewhere where we're unfamiliar, we're in a brand new world, and we pass through this sort of portal to be able to see a new world or see the world in a different way. And this same metaphor is used in other literature as well. So hopefully if anyone doesn't get Alice in Wonderland, you'll know this particular film. Anyone got it? Shout it out. Anyone? Thank you, Matrix. So this is the Matrix, and actually, it's kind of interesting when you look at this film. I'm just going to pause it there. When you look at this film and notice some of the Alice in Wonderland references. So if you know this film well, you may know some of these references, but right at the beginning of the movie, Neo gets woken up by his computer telling him to follow the white rabbit. And there's a white rabbit tattoo on the lady that he follows. So that's another reference to following that rabbit down the rabbit hole. And then when he gets offered the pills, so the blue or the red pill, he talks about the fact that, you can wake up in your bed and believe what you want to believe, or you can go further down the rabbit hole and see Wonderland. So it really is a reference to the fact that this movie also is that whole taking a step through that portal to be able to see a whole new world which wasn't available to him before. So seeing that, having that observability into that particular environment. And that's kind of what we want to achieve when it comes to remote cloud-native applications. When we're deploying our applications remotely into the cloud, often it's like we're shielded from this, being able to see directly into our applications. It can be quite hard to do root cause analysis on potential issues, bottlenecks, problems that we might face. So how can we create a portal to be able to step into that cloud-native world, to be able to understand how our applications are behaving and if they're behaving in a way that we want them to? So we're trying to create this portal through observability and telemetry. And that's what we're going to be covering today. So that's why I chose the title Through the Looking Glass. And hopefully you guys will now remember it with Alice in Wonderland or Matrix, whatever you prefer. So for the agenda today, what we're going to do is really cover why we care about this topic. So why do we need observability? We're then going to delve into the what is observability. So what do I mean by this term? After that, we're going to take a look at how. So how can we achieve this within our own applications? And we're going to delve into the specific open source frameworks of OpenTelemetry and MicroProfile for this. And then we're going to have a demo, as I mentioned, which Reece is going to take over. So thanks, Reece, for doing that hard part for me. And then after that, we're just going to do a summary with some resources if you want to check it out after. So the first thing is why? Why do we need observability in our applications? I kind of touched upon it a bit with that sort of analogy of the looking glass. But really, it's this reason of, well, we've had this evolving infrastructure. So our applications are now being deployed into environments where we have loads of different infrastructure services that we're utilizing. We might be switching between different cloud platforms, for example. We're utilizing virtualization, containerization. And this evolution has meant that we have a more complex infrastructure that we're deploying into. And not just that, our applications are now more complex. Instead of having one singular monolithic application, we're now moving into more sort of distributed services, whether that's macro services or microservices or even functions. We're now moving into this sort of environment where not only is the infrastructure more complex, but our applications are as well. Now, when it comes to developing for the cloud, what we want to feel like, and the reason we're so excited and we come to sessions like this about cloud native, is this feeling here. This, ooh, the cloud. We get very excited by it. We get excited by the prospects and the behaviors that it can enable. Hopefully you've seen Toy Story. If you've not, please take that away as homework. Awesome movie. Love a good Disney film. So it's this excitement that we feel, and this is the reason we want to build effective cloud native apps. However, what it can really feel like in reality is a bit more like this. It can feel frustrating, it can feel annoying, it can be really hard to be able to have that root cause analysis, to understand how you can do incident resolution. So being able to know things like, what's the overall health of my system? What is the root cause of errors? What are the performance bottlenecks? And which of these problems could impact my user? To be able to really ensure you have that accurate and consistent user experience to be as good as possible. So what we're going to do is take a look at, okay, how can we at least get rid of some of this feeling when it comes to understanding those questions when deploying to the cloud? And for this, we often turn to methodologies and sort of advice that is generic that we can apply to our applications. One of the most popular is the 12-factor application methodology. It has been expanded in recent years to be the 15-factor app methodology, really originally named. All it is it's basically just the 12 factors with a few modifications and additional 3 factors. I've made it really easy for you, and I've highlighted the additional 3. So hopefully it's super easy to follow. But importantly, where this has sort of added a factor that we're interested in for this presentation is this telemetry factor here. Now, you might notice that we also still have logs in there for those that are keen-eyed. They are sort of separate in terms of this factor methodology, being able to have sort of more logging as a more sort of internal tool when you're doing that development locally, and telemetry referring more to sort of real world, deploying your application into the wild, essentially. What happens when it's already out there? How is our application behaving in real time then? And so this is where the two kind of link together. But this has been a really important step in really acknowledging that telemetry is a vital part of developing cloud native apps. This is from a website called Splunk, who actually helped to create OpenTelemetry and have their own engineering platform for this as well, for security and telemetry. And these are some of the reasons that they come up with, why it matters. Why do we care about observability leading on from that 15-factor methodology? One thing, it helps us to improve performance. If we can know how our applications are behaving in real time, we can then analyze and understand, okay, if my application isn't behaving correctly, then why isn't it? Where's the issue? Can I tackle that and improve my performance and ensure that I've got that user experience all the time that our users are expecting now? It also allows us to be able to centralize our data, so to be able to capture data from all aspects of our deployed applications and really have them in one central location so we can analyze it all at once and in conjunction with itself. Integration, it allows a very easy integration, especially across multiple different microservices and different systems, and importantly, enables us to troubleshoot faster. Our applications, as perfect as we might be as developers, our applications are rarely perfect. There are issues that might crop up, whether it's your particular service or maybe a third party that you're depending on. We need to be able to have behaviors in place and systems in place to be able to troubleshoot those issues as soon as possible and to be able to mitigate them for our users. So that's the why we care. Hopefully I've convinced you to stay in this session. Cool, nobody's left, great. Okay, so what do we mean by observability? So this is a phrase that was kind of coined really sort of back in something called control theory. So this is kind of an area of engineering that's concerned with automating the control of a dynamic system. So whether that's water that's going through a pipe, for example, or things like the speed of an automobile over inclines and declines, it's all about providing sort of highly granular insights into the behavior of a system, along with providing rich context as to why that's going on. So in general, this is something I put together for like a generalization of what observability means. What we're referring to here is the extent to which we understand the internal state or condition of what might be a complex system based on our knowledge of only external outputs. So based on what we output, can we understand what's going on inside? When we apply that specifically to IT and specifically cloud computing, we get a more specific definition like this, really referring to, okay, can we make use of specific software tools, technologies, to be able to aggregate, correlate, and analyze a steady stream of performance data? So that's that output coming in. We're being more specific here with what output we're expecting, and be able to sort of effectively use that to monitor, troubleshoot, and debug our application and the network. So this is essentially what we're aiming to achieve when it comes to enabling observability in our systems. Now, some people might be questioning, okay, that's a good definition, but how does it really link in with monitoring? Because I kind of already have monitoring tools available. I do already monitor my application. It's not that we want observability to replace monitoring, not at all. It's really more of an evolution of monitoring and to enable more effective monitoring in a cloud-native manner. So enabling things like better application performance monitoring and network performance monitoring. So a combination of the two. So here we've got a definition really that monitoring is about sort of raising warnings whenever issues occur. So being able to tell us the average response time, for example, if it's getting slower and slower, or if there's growing request numbers that are resulting in errors, for example, or maybe bottlenecks. So monitoring helps us with that. What observability allows us to do is really to take this monitoring and to provide context and further insights into it in a cloud-native manner. So really, this is all about providing that detailed visibility and enabling us to, importantly, identify the root cause. It's all well and good if you know something's wrong with your application. If you can't do anything about it, that's pretty naff. You're just going to watch it fail. So really, what we want to be able to do is understand why it's failing, not just how it's failing. So that's where this evolution comes in. So that's kind of my definition of what that term observability really means and what we're trying to achieve here. Okay, so how can we do this with our own applications? So when it comes to actually implementing observability, it's actually quite conceptually simple. The hard part is coming to actually doing it yourselves. So when it comes to conceptually, I say there are 3 steps to implementing observability. The first step is we actually need to get some data. And to do that, we need to instrument our applications. And this is the step we're going to focus on mostly today. So in here, basically, we want to be collecting relevant information, whether that's metrics, traces, logs, or other data that we can utilize to understand our application. Once we've instrumented our system, we then need to send that data somewhere. Because if we're collecting the data and sending it nowhere, it's no use to anyone. So we do need to send it somewhere. So there's a load of different systems that you can send it to. It's really up to you. But the important part here is recognizing that that data needs to be sent to a separate system that we can then use to store and analyze that data. And the third thing is, okay, now that we've stored it, just storing it isn't going to be much use to anyone either. Because if you've just got a huge database of data that you're not utilizing, who cares? So really what we want to be able to do is really provide visualizations and, importantly, insights into how that system is behaving as a whole and be able to do things like query capabilities to really dive into potential problems or root causes and analyze that information. So these are the 3 steps, and we're going to go through 1, as I said, in more detail, and then briefly cover 2 and 3, and the demo will mostly be focusing on that first step. I know we've got some people in the audience who actually work on some of the systems that allow visualizations and insights. So they have talks. So please look at the DevOps schedule to check out, I think, Carly's session 5:30. Check out Carly's session where you see sort of use of one of those tools. So there are other sessions that sort of link into this that you can see for the second and third point today. So first point, instrumentation. When it comes to instrumentation, there tend to be 3 key pillars that enable observability within applications. And these really are key to being able to provide insights at different levels of your application when it's deployed. So those are logs, metrics, and traces. But there are additional pillars that aren't yet implemented in things like OpenTelemetry, but are hopefully there are other data that you could collect and could consist of provide other pillars for this brilliant Colosseum that I've created. So here you could also have things like end user monitoring. So being able to actually understand how your users utilize your system, where that request goes, how it interacts as it goes along that path. We've also got things like profiling. So being able to understand how your application runs in terms of resource usage, running it multiple times and being able to do sort of a diff essentially on that to understand, okay, where is the potential bottleneck? And right down to the very code line to be able to actually understand why that bottleneck occurs and causes that potential resource restriction. So profiling and end user monitoring are 2 that we could potentially consider for future use. But right now, we're just going to focus on these key 3, which is logs, metrics, and distributed traces. So when it comes to logs, logs, as I'm sure many of you are aware of this in terms of what a log is and how to use it, because you're probably using it in your own application already. But logs really are important in terms of enabling us to be able to sort of understand system behavior. They're found in almost everywhere in software and have been heavily relied upon by developers for many, many years. So you're probably already utilizing this one. The nice thing about this is that it really enables us to be able to understand specific information, and typically we'd store it in things like log files, for example. It's kind of that sort of more coarser-grained or higher-level information about system behaviors like errors or warnings, that kind of thing. So they're fairly simplistic, fairly easy to implement, which is the nice thing, and fairly important in terms of providing that base level of understanding what's happening in our system. They're not the one thing where I would say logs is sort of restricted in terms of its insights that it can provide is the fact that it doesn't necessarily associate those errors or warnings with a particular user or a particular request or transaction. So it lacks that context that we get from other things like traces or from things like metrics. It also doesn't really allow us to collect numerical data over a long period of time. We might be able to see how many logs we're getting and particularly why, but it doesn't give us information as to the health of our system or the performance necessarily in terms of resource usage. So that's why we need to use it in conjunction with the other two pillars. Now, you can, if you're not already logging, please log. I would say that as the first one. We have lots of different tools available for logging, so you're not short on any tools to use, and often the runtime that you're making use of already has logging enabled and logging features to be able to correlate that logging and provide it in an output that's convenient for you. So it should be fairly easy to implement this one, so I'm not going to spend too much time on it. The next one is metrics. So metrics really allows us to focus more on that numerical data. So more about understanding not just the infrastructure, but also the application over a period of time. So how is it behaving over that period? It includes things like system error rates, and also we're getting into resource usage here. So things like CPU utilization, memory utilization, request rates for a given service. So here is where we're getting more sort of data that's more malleable to mathematical, probabilistic, and statistical analysis. So being able to do things like sampling, aggregation, summarization, and correlation. So this is where we start getting into the depth of why is it behaving like that and when does it behave like that? What particular environmental factors are involved when my application is in this state? So this is giving us much greater insight into how our application behaves as a whole over a period of time. The way that we can implement it, I should say the biggest drawback with this in terms of, we've got logs, we've got metrics, why do I need anything else? Well, the biggest drawback with logs and metrics is that they are system scoped. So it makes it hard to be able to understand anything else that's going on inside a particular system, especially if you're relying on multiple systems. So that's why we need the additional pillar, which is traces, which I'll cover in a minute. The way we can implement metrics is we have lots of different open source frameworks and tools available. So MicroProfile is one of them. Anyone come across MicroProfile? Hands? Oh, there's actually not very many hands. I was expecting more. Oh, okay, perfect. Well, I'm glad I've got an introduction. So, MicroProfile. This is a fantastic open source-led specification. This is all about enabling sort of cloud-native behaviors and features in Java EE and Jakarta EE applications. So these are some of the APIs that they enable. There's also some that are standalone projects that the same community works on. There's a bunch of different people who work on this. Some organizations, so we have people within IBM who contribute to this specification. Some are just individuals interested. So if you are interested, we're always looking for more contributions. So check it out. But here at the bottom, we have sort of the core APIs. We've got more of the integration level and more of the observability level. And you can see here we've got things like OpenTelemetry, which we'll be leading into nicely. But we've also got things like open tracing, being able to check health, and importantly here, metrics. So we can actually utilize MicroProfile to be able to implement different metrics within our application if we're already using a compatible implementation. So if you're already using cloud-native runtimes like Quarkus, Payara, Wildfly, OpenTelemetry, which we both work on, and there's a bunch of others. So if you want to see which are compatible, there is a list on the MicroProfile website which tells you which runtimes are compatible with which MicroProfile versions. The most recent of which is 6. I think I need to update this because I believe people I think Payara or Wildfly might be on a beta for 6, so I do need to update this table. But if you look on the website, the link is at the top. It should tell you the most up-to-date information. But essentially, lots of choice is the key thing here. So you're not locked into a particular vendor, which is the nice thing about using MicroProfile, because you have that flexibility and that portability that we want when we're building cloud-native applications. So if you're interested in metrics and finding out more about that, then definitely check out MicroProfile Metrics. It was really designed to be able to provide this unified form of providing and sort of exporting monitoring data. So really exporting all that numerical data that we want in an easy to consume manner that can interact and make use of other backends to be able to visualize that data. So definitely check that out. We actually have a guide on that. Reece and I work on the guides. If you head to the openliberty.io website, we've got a whole guide section, which we'll show you later. We have a metrics guide. So if you've never used it before and you want to get started, great place to start. It only takes 20 minutes. So check that out. Okay, moving on to traces. So as I mentioned, the limitation of logs and metrics is that they are system scoped. Traces really allows us to be able to widen that, to be able to understand how operations and requests are linked and how they sort of transverse between multiple different services as the request goes on. So this allows developers to really trace, hence the name, trace the path of an end-to-end request as it moves from one service to another, letting us really pinpoint errors or performance bottlenecks in individual services. So really allowing us to figure out, well, that request went wrong, but where did it go wrong and why did it go wrong? Where can I pinpoint in that request sort of pathway what happened and what went wrong? So that's why traces are really useful with this and why they're needed in addition to just logs and metrics. There are some key concepts that you'll need to be aware of if you want to make use of tracing. So I'm just going to cover a couple here. The first is the actual trace itself. So it's fairly straightforward, kind of as the name suggests. It basically represents requests and consists of multiple spans. So as we can see here, we've got multiple services in our diagram, and we've got this trace that goes from right from the browser application all the way through. So tracking that path of that request. Then we've got spans. So spans are representative of a single operation in a request. Normally it contains things like a name, time-related data, log messages, for example, and metadata to really give us information about what's going on. So traces are just spans together. So understanding that all as a whole. However, excuse me, sorry. So in this diagram, we've illustrated how a trace begins in one service. In this case, we've got an application running on a browser, and it continues to call to an API web service, and then even further to a background task worker. So this is just one example of how you might see a span and a trace. However, what we don't have yet is context. So we need to add context in as another key concept here as well. So this is an immutable object. Oh, I need a drink, sorry. Talked too much today already. That's better. Okay. So yeah, it's an immutable object that really contained in the span data to help us identify the unique request that each span is part of. So it allows us to be able to track that request over the multiple spans to understand the trace. So you can see here, it mostly consists of two different values, which is shown in the diagram. We've got the trace ID and the parent ID. So what the trace ID allows us to do is to be able to link these different spans together in the same request path. So we can understand they're all part of this trace. What the parent ID allows us to do is really to be able to understand, okay, what was the service before this? Where did this come from, this request? To understand how those are linked together. Sorry, dry throat. Okay. So now that we understand telemetry and we can understand why it's important to our application, and we understand, metrics and logs are also important, how can we enable this? Oh, I'm going to need a bigger drink after that. Right, so OpenTelemetry. So essentially, when it comes to logs, metrics, and traces, it can be quite difficult if you're trying to get observability within your application and you're using loads of different frameworks. You're having to understand how each of those individual frameworks or tools needs data exported, how it needs it imported, how it's able to analyze. And so basically, to be able to sort of create a standard for this, we introduced this concept of OpenTelemetry, which is what we're going to be focusing on our presentation today. So really, this was designed as a standardization for data format for sending data to an observability backend. So basically, this is what it is. It's a high-quality, ubiquitous, and portable telemetry to enable effective observability. So providing that I'm so sorry. Oh, just getting over a flu, and I think my throat's still not used to speaking this much. Please excuse me. So essentially, it is a collection of different tools, APIs, and SDKs, and you can use it to be able to instrument, generate, and collect and export telemetry data. Now, the nice thing about this is that it enables you to have that standard without specifying which tools you have to use. So it still allows that flexibility and that portability that we were talking about when it comes to different applications, depending on what you're using. So the one thing I would note with this is don't make the mistake of assuming that OpenTelemetry is a full observability backend. It is not. It is there as a standard for data export and import of different sort of observability data. But the important thing here is that it's not an observability backend like, for example, Jaeger or Prometheus. Instead, it just supports that exportation to a variety of those backend tools. So you can make use of any of the tools you want, but don't make the mistake that it is a full observability backend. The way that it came about was really this need for standardization. So originally, when we first thought about the fact that, yeah, we probably need standardization, people were like, okay, great, let's build standardization for tracing, and let's build it using census. And we had 2 open source frameworks, and some bright spark came along and went, isn't that 2 standards instead of 1? And so then we realized that actually it wasn't a standard because there were still 2 standards. And so these got combined into the project of OpenTelemetry. So this really is designed to be the standard, not just multiple standards, of how we enable effective observability. So if you do want to check them out, you can still read the websites for OpenTracing and OpenCensus. So OpenTracing was about sort of sending telemetry to an observability backend, but it relied on developers to be able to implement their own libraries to meet the specifications. So not all that handy. Then OpenCensus provided a language-specific libraries that developers could use to instrument their code and send it to any of the supported backends. But really, now that we have OpenTelemetry, we can just use this one standard instead. So these have been sort of essentially the support has stopped for them. So it's encouraged that you just go straight to OpenTelemetry and not consider using those separate standards. This is a diagram of the way it works because we're all developers and we want to know how instead of just high-level concepts. So this is how it works. So what we have is we have our different sort of microservices or infrastructure components that are all producing data that we want to be able to collect. And we collect that using OTLP. We're developers, we just can't get enough of acronyms. We just love them so much. OTLP stands for OpenTelemetry Protocol. That's it. Really, all it is a specification that describes how we want to encode, transport, and deliver the delivery mechanism of the telemetry data between our telemetry sources on the left-hand side and intermediate nodes such as collectors and telemetry backends. The collector here is that intermediary that I just spoke about. Here we have the OTel collector. This is a vendor-agnostic implementation on how to receive, process, and export telemetry data. Usually it's a single binary that can be deployed either as an agent or a gateway. And then we have at the end some of our backends. So whatever backend you want to use, you can use as long as it implements OpenTelemetry, which there are lots of different tools that you can make use of. Deep diving into this middle component, the OpenTelemetry collector, this is kind of what it consists of. So as I mentioned, this is a vendor-agnostic implementation of how to receive, process, and export that data. It basically removes the need for us to run and operate and maintain multiple different agents and collectors. We can just have this one standard, again, referring back to that standardization. This works with improved scalability and supports open source observability formats like Jaeger, Prometheus, FluentBit. So again, talking about that portability and that flexibility depending on what your application needs. And it can send it to one or more open source backends. So here we have in the middle here, we have some of our sort of where we're collecting our data from, whether that's in Prometheus format or Jaeger or from the OTLP. And here we have our receiver. So the receiver is how we get data into the OTel collector. Generally, a receiver accepts data in a specified format, translates it into the collector's internal format, and passes it to the processors and exporters that are defined in our application pipeline. And then we have the exporter over here. So once we've done some processing, and that really depends on what we're determining that processing to be. Once we've done that processing, we then have the exporter. So similarly to the importer, to the receiver, the exporter is really about it's just a component that allows us to send data to different systems and backends, again, depending on what tools we want to make use of. So that's essentially how you can enable OTel collector for that intermediary component. You might be wondering, under what circumstances would I want to use a collector to send data as opposed to just having each each service send its own data over to the backend? Well, for trying out and getting started with OpenTelemetry, sending your data directly to a backend is a great way to get value quickly. Don't get me wrong, I understand the need for speed. However, in a development or small-scale environment, that's fine, but in general, we recommend using a collector alongside your service because it allows your service to offload data quickly, and the collector can take care of things like additional features like retries, batching, encryption, and often sensitive data filtering. So the fact that it enables these additional components rather than just trying to quickly send your data across. So it has that central place for all of that. So we would recommend, especially on production systems, using a collector and not just sending your data straight across to those backends. Okay, so that's my whiz through of why do we care about observability? What do we mean by observability? And how do we do it utilizing things like OpenTelemetry? However, everything I've said so far has been pretty high level. I'll give it that. Right? I've not really delved into yet how you actually go about using this. So that's what Reece is going to do now using MicroProfile. So over to you, Reece.
Thanks, Grace.
Do you want the clicker?
Yeah, cool. So like Grace mentioned, you know about OpenTelemetry. Now we'll go into MicroProfile Telemetry 1.0 and what exactly it is, how it's improved observing applications. So it adopts OpenTelemetry tracing. So your MicroProfile applications, I'll say MP for now, just because it's easier, benefits from both manual and automatic traces. So it's, like I said, it's been adopted using OpenTelemetry tracing. It's introduced in the MicroProfile 6 release. It's a set of SDKs, APIs, tooling, and integrations. And in essence, it's designed for the creation and management of telemetry data, i.e. traces. Also in the future, we hope that MicroProfile Telemetry evolves to include OpenTelemetry Metrics and OpenTelemetry logging as it doesn't already.
Sorry, yeah, sometimes my clicker doesn't work.
I'll just use laptop for now. Right, so what exactly are we looking at? There are 3 different types of instrumentations. We have automatic, manual, and agents. Starting with automatic, if you have Jakarta RESTful web services and MicroProfile REST client automatically enlisted in distributed tracing, this works for you. Likewise, with manual instrumentation, it can be added via annotations with @span or via CDI injections. And don't worry if this doesn't look too familiar to you. I will be showing it later in the demo. The one thing I won't be showing today is agent instrumentation, as this uses OpenTelemetry Java instrumentation projects to gather the telemetry data without need for any code modification. So how exactly does it work? This is a great diagram to basically explain what exactly is going on. So it's a system that has 2 services that both have applications running on OpenLiberty. With MicroProfile Telemetry 1.0 installed, the requests and responses generate spans, and the paths between the services are monitored using their context, as you can see via the diagram. The spans are then exported to a backend service where they can be viewed in the user interface or in the console logs. And I'll go a bit more about the backend exporters now. So you can actually export this data into the MP telemetry, which collects multiple exporters. So you can use Jaeger, Zipkin, and OTel Collector. Today we'll be using Jaeger. And finally, we'll talk about the visualization. So we have Prometheus, Grafana, and Kibana. So Prometheus collects rich metrics and provides a powerful querying language. Grafana, on the other hand, transforms metrics into meaningful visualizations. Both are compatible with many, if not most, data source types. And in fact, it's very common for DevOps teams to actually run Grafana on top of Prometheus. Prometheus, however, is not actually intended as a dashboarding solution. So the open source Prometheus monitoring tool offers a built-in dashboarding functionality, even though it considers Grafana as its visualization solution. Both the Prometheus dashboard and Grafana allow users to query and graph time series metrics stored in the Prometheus database. So deciding whether to use Grafana with Prometheus really depends on your monitoring requirements. The key difference between Grafana and Kibana really states from their purpose. Grafana is designed for catering towards analyzing and visualizing the metrics such as system, CPU, disk, and I/O utilization. However, Kibana runs on top of Elasticsearch and is used primarily for analyzing log messaging. And this is just a couple of images that show the different types of systems. So we have Prometheus on top. As you can see, it's more of the basic logging UI, whereas we have Grafana and Kibana, which is a bit more colorful, has a graph, so it's easier to visualize. Right, now we're going to get into the demo. This is the meaty part. This is my favorite part because I've worked on this. And I will say we have used OpenLiberty. So this is our cloud-native runtime, which enables you as developers all these key advantages. So it's easy to focus on code. Show of hands who's used OpenLiberty before? Anyone?
Oh, cool. Nice.
Okay, we've got a few people. Well, if this is all new to you, I'll show you all the benefits of why it's so good. Our dev mode is amazing. It's easy to write tests, fast and iterative changes. For your test containers and test integrations, we have true to production testing as much as possible, of course. And we are ready for containers, not to mention our tools and flexibility. It is a modular framework, so it's perfect for what you need. It really is a plug-and-play model. So if you are really interested in OpenLiberty, please take a look at the article below or check out the website. And just to add on top of that, we have some reasons of why it's great for our developers in terms of productivity. As you can see, we're compatible and we use IDEs such as VS Code, IntelliJ. We have builds, APIs, and testing. And we have a great community who are always willing to make it better. As you can see, we have great responses as well on Twitter. Right, so the demo I'm going to be going through was created by Yasmin. It's a simple demo to basically show you how to collect traces from multiple services. All of this is open source, so please feel free to check it on GitHub. And if you do find any issues or if you do want to make any comments how to make it better, because it's open source, feel free to leave an issue there and we'll get to it and we can contact you regarding that. That's one thing that's really good about OpenLiberty. It's all open source, so you can take whatever code you want from us. So just as a smaller breakdown of what the demo is, it's taking app without telemetry, adding in the telemetry via OpenTelemetry, MicroProfile, and OpenLiberty. So I'll get to it now. Sorry, I hope everyone can see. Please let me know if you would like it bigger in terms of the text.
Do you want to make the text on the right a bit bigger?
Yes.
Just for those guys at the back. Can you guys see? Yeah?
Can everyone see that?
Perfect, got thumbs up, thank you.
Perfect, thank you very much. So we'll get into the demo itself. And like I said, this is all online, so feel free to take it and check it out. So we have the demo itself. I've already cloned down the repository. To do that, you would simply just go to this link here and as you're aware, just copy it in and get cloned down. Right. Now, so as mentioned, we are using Jaeger servicing. So to get started, we'll go to their website. As you can see, they have a documentation for their instrumentation. And what we want is their all-in-one executable file. So let's copy that down here. Hopefully that runs perfect. Great. So that all works. And to ensure that works, we can check it on their website, which is their UI. So this is a great way to basically see what's going on behind closed doors. Now, so we're going to start with the automatic instrumentation. As mentioned before, there was 3 different types of instrumentations. We won't be showing the agent, but the automatic starts. And for this, we observe traces while modifying the source code in your Jakarta RESTful web service. So as you can see in the system service, what we need is MicroProfile 1.0, because that's what we're talking about today. And we will get it up and ready over here. So let's comment this out.
I'm just going to quickly interject and just say that with this application, it's based on 2 microservices. So it's pretty simple, but it's designed to be simple. So don't think this is a production-ready system. This is just to teach you how to use OpenTelemetry. The system microservice, that's just getting system data every 15 seconds, and then it's sending that to the inventory microservice, which just stores a list of all your systems and the most recent data, which you can access with a REST endpoint. So fairly simple application, just 2 microservices working together. But the nice thing is, it's the same app we use for all our guides. So if you try this one and want to try out more of our guides, it should be fairly simple to follow. Yeah.
Thanks, Grace. So by default, MicroProfile Telemetry is actually off. So what you want to do is go into the properties file and make sure that everything runs as the demo says. So we have the SDK disabled equal to false, and our exporter is specified to Jaeger. So if you were to use Zipkin, for example, that would be Zipkin instead of Jaeger, of course. Now we can start the system, what Grace was mentioning earlier. So we can cd over into system.
So this file, this class that Reece has just edited, this is part of the MicroProfile config API. So this is another API we're using from MicroProfile, from that specification I showed. This allows us to be able to have external configuration files that are separate to our normal classes, where our application code is, so that we can have that one place where we can change that configuration. So if we're deploying to multiple environments, it's much easier to have that externalized configuration file and change just one value there, rather than having to go through all our classes and change all of that configuration. So that's a great API from MicroProfile that we're making use of here.
And as you can see, the default server is started. So if you were to use OpenTelemetry, you'd see that and you would know your system service is running. So we can actually check the endpoint, and hopefully there'll be a span for this request that we've made, and it'll be under system. So we can see that it's currently working. Now, if we go to the Jaeger UI, refresh it, we should see the system service here. Hopefully that runs. And yes, so this is the trace, and we can see the spans in between and all the relevant information as well. So that covers the automatic instrumentation. Now we'll move over to the manual instrumentation, so you can actually edit your code by yourself. So we will leave the system running, and we have some prerequisites for the automatic. So we want to first go to the server XML and make sure that we have some visibility for this third-party API.
I'm just going to get a photo of you.
Right, so as you can see here, we have the web application location, which is the MicroProfile, what we're using today. However, we need a third-party visibility. So all we do is copy that in down here. Perfect, and get that saved. Now the next prerequisite is the OpenTelemetry API and the telemetry instrumentation, and this will be in our pom.xml file under inventory. So as you can see, I've already commented it all out so you guys are aware, but the demo shows it for you anyways. And this is just highlighting the dependencies that we use for the OpenTelemetry APIs and the instrumentations as well. So we get that saved. Now here comes the best bit. So this is the actual manual instrumentation of the application code itself. So we are all set to instrument our code manually, creating our own traces. So we start by injecting our own tracer and span object. So for this, we should go down to inventory resource. Yes, perfect. We've got it here. And all we have to do is copy that in, or in this case, I'll uncomment it. Perfect. And then this can then be used to create spans. So for example, a span called getting properties starts and the event is added before the system service is called. So what we'll do is likewise, instead of copying it over, I'll just uncomment this all. Perfect. And we save that. So we can actually also create new spans by annotating any methods in the Jakarta CDI beans using @with span. So as mentioned before from the previous slide. So this will be located in the inventory manager file, which I believe is here. Perfect. So we have the two. We have the @with span and we have the @with span with list. So the hostname method parameter is annotated with span attribute annotation to indicate that it's part of the trace itself. Hope everyone can see that. So I'm just going to uncomment it or copy it in, whichever one you would like to do. For both. Perfect. So this was just a demonstration of how you would create the spans manually, and we built this in the inventory service. And now what we're going to do is deploy it to OpenTelemetry, and you'll be able to hopefully see it on the Jaeger UI website. So for this, what we do, we need to make sure both system services are running. So we need to make sure, I think the start, so the system is already running. Now we need to cd into the inventory and run it here. Perfect. While this is running, and as you can see, the message comes out again. The default server is ready to run. So we should hopefully be able to see this image here, which is 5 different spans, 4 being the ones you created just now from inventory, and the 1 from the system, which is what we created earlier. So we know that it's running. And hopefully, let's go back, refresh. So before you could only see system, now we have inventory running now. And it should be there. Perfect. So now you can see the 5 different spans, 5 different traces, sorry, and then you've got the spans as well. So you can take a look at all the different type of information, and it's come out as expected. And that will be the end of the demo. All these spans were basically one single trace that's emitted from the REST request to the endpoint. It is easier to identify the source of inaccuracy or accuracy, or latency, sorry, in a single request by debugging. So what we've done is basically just shown an easy way to see what's going on in your application. And that's why it's really important. And as you can see, if you carry on going down through the demo, you will be able to look into the Java instrumentation. So if you are agent instrumentation, so if you are interested, please take a look in your own time. And we'll head back to the presentation. Does anyone have any questions regarding the
demo part?
If anyone didn't get anything or if you didn't see it. It is all on our website. I'm actually creating the guide itself, which is what makes me a subject matter expert for this. I'm creating the guide for the MP telemetry, so hopefully it will be out in the next month or so. But feel free to keep an eye on our OpenLiberty and website and socials to see if you find it.
Great. Okay, so we're just going to wrap it up now. Thanks, Reece. Appreciate it. So yeah, as we said, that will be hopefully available as a guide. So if you are interested in trying that out, you can either use the instructions that we've got referenced at the end here, or you can look out for that guide coming out in the next few months. In summary, hopefully what we've shown you here, that yes, we are entering our applications into a world of increased complexity, and sometimes that can be a little bit daunting. However, hopefully what it really emphasizes to you is how important and critical observability is to that in terms of monitoring and understanding how our applications are behaving in real time in the wild. And the nice thing is that you're not alone. We're not expecting you to do this all by yourself. The nice thing is there's a whole community behind open source tools that we've talked about, like OpenTelemetry and MicroProfile, that are there to hopefully make this a bit easier for you to be able to try out and implement in your own applications. Just in case we haven't given you enough homework already, because everyone loves homework, there are some extra resources here if you did want to go into this subject in a bit more detail. What is observability? Looking at how we can enable it with OpenTelemetry and MicroProfile, and that demo, which is linked to in this blog that we have at the bottom if you did want to have a go yourself. As we mentioned, we do have the guides. We already have some observability guides there already. We have a whole subsection for observability, which takes you to how you can utilize OpenLiberty with lots of different backends, and look out for the one that Reece is making, which should be out soon for OpenTelemetry. The nice thing is with these guides, you don't have to do them locally if you don't want to. So if you have a restricted machine, the nice thing is that we have a browser-based IDE that you can utilize. So all you need is a browser to be able to get up and running with this, and it only takes about 15 to 20 minutes for each guide. So hopefully nice and easy for you to have a go, especially if you're interested in any of those MicroProfile or Jakarta APIs that we mentioned earlier. And if you want to find out more about news on OpenLiberty and new guides that we have coming out, like Reece's, then please follow us on social media. I help run it, so I'll say hi if you come follow us. Would appreciate any likes or follows if you fancy. But with that, we're going to say thank you very much for coming to this session. Hopefully you found it helpful. It was actually Reece's first in-person presentation, so thank you guys for being the audience in that. Appreciate it.
Thank you, everyone.
We have 1 minute, so I can maybe take one question and any other questions after. We got one at the back? Yeah, perfect. Nice and easy for the microphone.
So my question is basically around the instrumentation on the client side. I know with regards to sending what's it called memory-related metrics from the client side. I just don't know, is it something that is catered for as part of the metrics? For example, heart of memory error exception, is that something that OpenTelemetry covers as well? I mean, the MicroProfile specification, is that part of what covers? Because one of the things I've noticed is you don't get to see those type of, you won't be able to troubleshoot those kind of exception when it happens, especially given the fact that my Docker and containers are now good at telling you when, you are running out of memory.
So,
I just wanted to tell that.
Yeah, so I should clarify here that, so you've got logs, metrics, and traces. OpenTelemetry covers all of that. However, the MicroProfile implementation of it only covers traces. So that's why there's still MicroProfile Metrics as a separate API. So if you're looking at specifically the metrics, that's where you want to look at the MicroProfile Metric documentation, because that will tell you all of the different metrics you can collect. There's a whole list. I believe you can access the specific metrics you were mentioning, but I'd have to double check the documentation for that. In terms of OpenTelemetry, I'm less familiar with the metrics and the logging on that because it's not yet implemented in MicroProfile. So there is a differentiation between what's available in MicroProfile Metrics versus what's available in OpenTelemetry Metrics and how you make use of that. As Reece mentioned, the hope is that one day we'll be able to implement the OpenTelemetry metrics and logs in MicroProfile, but that's not yet occurred. That's still future development. Yeah, but thanks for the question. Appreciate it. Okay, time is up, and I know that people are hungry and want to go to more sessions. So please come and find us. We'll be around all day, and we're happy to answer your questions. Thanks, guys.